So looking at b now, again, I'm not going to do it the way they tell me to do it. I'm going to pretend we weren't given any hints. We just had to differentiate y equals 10 to the x. All right, so remember it has to be base e, it can't be base 10 for me to differentiate, for do calculus. So I'll make it base e. So if I put an e in there, I have to do the inverse function, which is logging, log base e. So I'm eing and logging 10 to the x, which means it's just 10 to the x. And if you think about that, x, the power using log laws can come down. So it's like it could be e to the 3x. In this case, it's e to the log 10x. So when we differentiate e to the 3x, think about it, e to the 3x. We would just have 3e to the 3x, and that's what happens here. We have log 10 e to the log 10. So I'm just putting the x back, and then you can see they cancel. So you just get log 10 times 10 to the x. I might put that in brackets there. Or maybe if I write it this way, it'll look a bit nicer. Log 10. Either way is fine. All right, so if I look at the second one, so looking at the second one, we've got y equals 8 to the 4x minus 3. So I'm going to write that as e log 8 4x minus 3, and that, of course, that 4x minus 3 can come here, can come down the front. Excuse me, sorry. All right, so the minus 3 part, if I expanded that, minus 3 log 8, excuse me again, that would just be a constant. So I'm really just looking at which part is the coefficient of x, which is 4 log 8. I'll get a 4 log 8 there. So it's the 4 log 8 that is coming down here, 4 log 8. And then I'm going to get, you always get the same thing. So I'm still going to get that e to the log 8 to the 4x minus 3, and e and log cancel each other out. So I've really got 4 log 8 times 8 to the 4x minus 3. So if you didn't understand that, I'm just going to go from here a little bit slow and just show you why it is. If I expand, so 4x log 8 minus 3 log 8, so that's the same as e to the 4x log 8 times e to the 3 log 8. So this part is just a constant. So it's like having a 3 out the front, and you just keep it out the front. All right, so that part you kind of don't need to worry about, and just come back at the end and put it all back together. All right, hopefully that helps. If not, ask me in class. All right, so if I look at the third one, all right, so what have we got? Y equals 3 times 5. So that 3 is a constant. Again, I could put it in, but I'll just leave it at the front. So it's 3 times, and I'm going to do e log 5 to the 2 minus 7x. So again, this power can come out the front, and I'm only interested in the coefficient of x. So when I do y dash, the coefficient of that x, so I've still got the 3 there, coefficient of the x is going to be minus 7 log 5. That's a log. So when I put that down here, it's going to, and expand it out, I'll get minus 7 log 5 as my coefficient of x. So if you can't see it, then you need to do it a bit slower and put it down here and then expand it out. All right, and then I'll still get this stuff. So if you can see it without moving that power of 5, then you don't need to move it, but if not, move it. All right, and of course e and log kind of cancel each other out, so we're going to get minus 21. I can't write log 5, that looks dodge. Minus 21 log 5 times 5 to the 2 minus 7x.